Okay, what is this? This is a polynomial function, okay? How do you recognize what a polynomial function looks like? You have, and it's written in standard form, what you're going to have is variables with positive exponents. You will never have something like this. You will never have a negative exponent. You'll never have a negative exponent. This is not going to be a polynomial. You will never have a variable that's under a radical. You will never have a variable underneath in the denominator of a fraction. These are not polynomials. So polynomial functions all have positive exponents. Now I have a question for you. Would this be a polynomial function? Yeah. You can have numbers under radicals. You could have this. But your variables have to have positive exponents. Everyone got that? Now, what do these look like when you graph them? They're continuous. They could look like this. They're very flowy. No breaks, no sharp corners, no turns. They're very continuous. You cannot have any breaks, no jumps, no sharp corners. It's all you're going to have maxes and minimums. And your left side sometimes is going to go up, your right side is going to go down, or they both might do the same thing. They might both go up, they might both go down. That's what we're going to investigate today. So, the graphs of polynomial functions are very continuous. If you see any jumps, holes, sharp corners, gaps, it will not be a polynomial function. So with that in mind, look at questions 1, 2, and 3. Would you say 1 is a polynomial or not? Could it be? Yes, it is. How about 2? Is this yes or no?
No.
Why? What's the reason?
Yeah.
That gap. So this would be a no. That would not be a polynomial. How about number 4? Yes or no?
No.
No. Because of the sharp corner. So that would not be a polynomial function. Everyone got that? What would the equation of this be? Absolute values. So that's another thing you want to look for. No absolute values. Okay? Now there's 2 different types of polynomials. One that has an odd degree and one that has an even degree. And I'm just going to put x to the 3rd and x to the 4th here. If the degree of the polynomial is odd, the left and the right behavior, so left, when I say left behavior, the left side, and the right side is going to be the positive side. It's going to look like this, where the left and the right side will do opposite things. Now, how do you know if the left side's going down or if the left side's going up and vice versa? So odd, the left and right are opposite. If the leading coefficient is a positive, it's going to look like this one, where the left side goes down and the right side goes up. If the leading coefficient is negative, the left side will go up and the right side will go down. Do you remember doing this last year?
Yeah. Thank you.
Okay. What if the degree is even? Well, both sides will go up if the leading coefficient is positive. And if it's a negative leading coefficient, do you know what they do? Let's make this a 4. Keep it consistent. If it's a negative, they'll both go down. So leading coefficient is negative. Do you remember this? So you have to remember, if the degree is odd, the left and the right side do opposite. If it's a positive leading coefficient, the left goes down, right side goes up. And if it's negative, the left side goes up, right side goes down. If it's an even degree, they both go up. or both go down? How do you know if they both go up? If A, which is the leading coefficient, is positive, they both go up. If it's negative, they both go down. And that's exactly what this tells you right here. Odd versus even. Odd, if A is greater than 0, which means positive, the left side goes down, the right side goes up. If it's less than 0, left side goes up, right side goes down. If the degree is even, if it's positive A, they both go up, negative, they both go down. And that's exactly what this talks about, the end behavior. They both go shoot up or shoot down, depending if it's even, or if it's odd, one side goes up, one side goes down. Now, if you look at a polynomial, like this one right here, this one's already factored for you. Yesterday we investigated how to break these up. So we've got this polynomial. By any chance, do you know what the degree of this polynomial is? Not 3.
6.
How did you get 6? You are correct.
Add it all.
She added them up. What did you add up?
2.
The 2, there's 2 of these zeros, there's 1 of these, and 3 of these. If you add these up, you get a degree of 6. So this would be an x to the 6th power. Does everybody agree? Now, if you were to FOIL this out and write it in standard form, your guess, and I'm sure you'll be right, would you get a positive leading coefficient or negative without doing the math? Why do you think it's positive? There's no negatives. So when you start multiplying this stuff out, this is going to be positive. So now can you tell me, is the left and the right side going to go up or down? They're both going to go up. Why? So it's going to look like that. Because the leading they're both doing the same thing because it's an even degree. And the left and the right side will both be going up because I'm getting a positive leading coefficient. Now the other 2 things that you need to talk about and know is how many max and mins are going to be in a problem. At most, there will be 1 degree less than this power. So how many turns will there be? At most, there's going to be 5. There could be, at most, the maximum there could be is going to be 1 degree less than this. So 6 minus 1 is 5. Now check out all the odd numbers less than 5. 1, 3, and 5. These are the possible. It could be 1, it could be 3, it could be 5. Why can't it be 4? Why can't it be 4? How could we do 4 turns? 1, 2, 3, 4. How could we do 4 turns and make the left and the right be doing the same thing? We can't. So there has to be either 5 turns, there has to be, see if I can do this, 3 turns, here would be 3, 1, 2, 3, or there could be 1 turn. That would be the only way to keep the left and the right side both going up. Get it? So you have to have, you look at your degree, subtract 1, and that's the maximum number of, we call that local extrema. The local extrema are the maxes and the mins. Now, if you take the degree, do you guys remember what the number is between a max and a min? We did it in chapter 3. What is it called? Inflection point. There will be, take this degree and subtract 2. There's going to be, at most, 4 inflection points. 1, 2, 3, 4. That's when it changes concave up and concave down. At most. You do 2 less. So now I want you to look at this. We have to talk about the multiplicity of each 0. Now, how many times did each of these zeros occur? This one occurred 2 times. -1 occurred 2 times. We say that it's an even multiplicity. If the degree of each 0 is odd or even, it will tell you whether the graph is going to touch at that 0 or cross through it. So if the degree is even, it's going to touch at it and bounce right off of it. If it's odd, like this one and this one, these are both odd, it's gonna cross right through it. Do you remember doing this last year? Even, touches, odd, crosses. Okay? So now, how are we gonna sketch the graph of this? Well, what are your zeros? -1, 2, and 3. So let's put a dot at -1, a dot at 2, and a dot at 3. Knowing that the left and the right side have to both go up, but at -1, what does it do at -1? It's gonna touch. So how would I graph this? If I just sketched a graph, a light graph, I'm gonna come from the left, I'm gonna touch here, somehow I'm gonna go up, I'm gonna come through here, and I'm gonna come back up and cross through. So that's what I think my graph, if I sketched it in my mind, that's what it should look like. Now, how will I be exact? How will I be exact? Did anyone see what I put next to your graph? A T-chart. What do you think you're gonna do? What kind of numbers, Lily, do I plug in? Should I try 10 or -10?
No,
No, why not?
because they're out of, like, I know where you're grabbing.
I wanna see what's happening right here in this area. So what kind of X values would make most sense to plug in? 0 and 1. Any other number you see that, do we wanna see how far down it's going? You'd wanna plug in 2.5. Where do you think you plug these numbers in? Into the equation. So can you help me out real quick? What do you get when you plug these numbers in? If I put a 0 in here, the best place to put it is where it's factored. What is 0 plus 1? 1. What's 1 squared? 1. What's 0 minus 2? -2. And 0 minus 3 is -3 cubed is -27. So if I multiply these, I get 54. Where's 054? Well, it's way off the page. Let's just pretend like it's right there. So what's really happening is this thing is shooting way up. Once it touches at -1, it's gonna shoot way up at positive 54. Then where's it gonna, it's gonna probably, it may even go up a little bit more. I really don't know. But this is just a sketch of it. What would I do for 1? Plug 1 in. 1 plus 1 is 2. 2 squared is 4. 1 minus 2 is -1. And then 1 is -2, and we're going to cube it. You get -8. Multiply these, you get 32. So it's on its way down. Over 1, and we're going to say, pretend like that's 32. It's going to come down. It's going to go through at 2. And it's gonna go, how far down? Well, we would have to put 2.5. And you would add it to 1, square it, and do all this math. I think you get something like -0.6. Anyone have a calculator can do it real quick? I think that's what you get. It's gonna come down. So in other words, how far down did this thing go? Not very. It's gonna go basically like right there. So that's how you would sketch this graph. So now, what happens when it's not factored for you? What are you going to have to do for this problem? How do I graph this? You gotta find your zeros. So what is the GCF of this one? X squared. You're gonna pull out x squared, and you get x cubed minus x squared minus 8x, and then plus 12. Now, how do I factor this? This is what you learned yesterday. Yesterday you did this. Unfortunately, you're going to have to do it on some of these. How do I break this up? Well, that's where you use your RZT test, your rational possible zero test. So, what you're going to do is look at, this is a real quick synopsis of this. You're going to look at what we did yesterday. You're going to look at possible factors of 12 over 1. So like 1, 2, 3, 4, 6, and 12. And one by one, you have to apply what you learned yesterday. you're gonna try, most of you would try 1. You would put a 1 here, and you'd say 1, -1, -8, 12. Quickly, synthetic division, bring down the 1, multiply, add, and do you get a 0 here? No, so guess what? 1 is not a factor. Try, what's the next possible? Try 2. So 2, 1, -1, -8, 12. Bring down the 1. 2 times 1 is 2. Add, multiply, -6, add, oh, look what we get. Look what we found. We uncovered a 0. So what do you have here? You've got x squared plus x minus 6. What are you going to try to do at this point? You're going to factor it. X plus 3, x minus 2. Now what did this 0 give you? What's that number going to be? X minus 2. Good job. So when I ask you to write this in factored form, and what are the zeros, you should write y equals, we took out x squared, we ended up with x minus 2. How many of them did we have? How many did we have? 2. And what else did we have? X plus 3, right? That's it in factored form. What are my zeros? 0, 2, and -3. Can you tell me the multiplicity of each one? Even, and odd. Why do I need to know even, odd? Why do I need to know what the zeros are? And why do I need to know the multiplicity of each one? Because we want to know when we sketch this, is it going to touch at that 0 or bounce right off of it? By the way, what's the degree of this problem? A 5. And the leading coefficient's positive. So that means I'm going to have 4, maybe 4 bumps. It's going to be going, I'm sorry, I don't know why I drew that. It's going to look like this. It's going to be coming like this. 1, 2, 3, 4. It's going to look like that. That's what your graph's going to look like. How many inflection points would there be at most? You take the degree and subtract 2. 3. Good. Can you tell me what the y-intercept of this is? If you put a 0 here, 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 and here, what do you get? You get 0, 0. So now, can you for me quickly graph this? Where should I begin? Where should I begin? At your zeros. Find your zeros. We have 0, we have 2, and we have -3. Everyone got that? 0, 2, and -3. Now, what do we know about the multiplicity of 0? And where is this thing coming from? Is the left side going to be coming down or up? What are we doing? Look at this. This is the shape of it. It's going to be coming up. Now, at 0, what should I do? Touch it or go through it? Touch it. Then what do I do? Bounce off of it. And then at 0, what is it going to do? It's going to come down, so it's going to do this. It's going to come down here. And then what's it going to do? Bounce off of it again, right? And then what's it going to do? Oh, wait. Sorry, guys. I went the wrong way. At -3, what is it? Odd. It's got to go through this. It's going to come down. It's going to touch at 0, because that's an even degree. And it's going to come up. What is it going to do? We don't know. And it's going to touch at this 0 and go up. So that's a general idea of what it looks like. How do I make it perfect? What would I do? And I don't want you to do it right now, but you would take a T-chart and plug in numbers like -2, -1, and 1 and see how high, because I really don't know how high it's going. But does everyone understand what multiplicity means in the shape? So it's going to cross through at -3, and at 0 it's going to touch and bounce, and at 2 it's going to touch and bounce. Now make sure your left and the right are doing opposite. Why? Because the degree's 5. Okay, here we go. Go to the back page. Number 7. 7, 9, and 11, I would like to know, can you tell me, looking at the left and right behavior, would you classify this as a degree of 3, a 4, or a 5? And why? What's your reason? So look at the left and the right. It's going to be odd, right? Because they're doing opposite. Count how many bumps we have here. There's 2. Add 1. So it's a degree of, I'm going to say this is a 3. The least degree it could be is 3. How about number 9? Would you say a 3, a 4, or a 5? A 4. Can it be a 5? No. Could it be a 3? No, because the left and the right do the same thing. And how about 11? Is it odd or even? Odd. Could it be a 3? Why not? 1, 2, 3. We have 4 of these, so you have to add 1. So the degree of this would be a 5. It's not going to be a 4 because left and right are doing opposite things. Okay? All right, 15, 17, and 18. There's 3 things I want you to do. I want you to tell me what the zeros are. What are the zeros? And let's go in order, least to greatest. -2. -2 is a 0. 1 is a 0. And 3 is a 0. Now, I want you to tell me, whoops. 3. Tell me, are they odd or even? What's this one? Odd. They're all odd. Odd and odd. Does everyone know what odd means? I'm not asking you, is that number odd or even? I'm asking you, at that 0, is it crossing through or is it touching? And they're all crossing through, so it's odd. Now, the last thing, can you tell me how to write this in factored form? Y equals, Caesar, what do you do? How do you write this in factored form? What do you write? X plus 2. Then what? X what? Minus 1 and X minus 3. You get this? Got it? Okay, number 17. Can you tell me what your zeros are? -2, odd or even? Odd. How about this next one? -1, odd or even? Odd. And how about this one? Odd or even? Even. So how will you write this in factored form? Y equals X plus 2, X plus 1, and X what? Squared. Why am I squaring that? Because it's touching and I need my degree to be 4. 2, 3, 4. It's the only way you're going to get that. Number 18. Tell me what this one is. I want the zeros. -2 and 2, and they're both even. What's it in factored form? X plus 2 quantity squared times X minus 2 quantity squared. Good job. Okay, so next, look at the bottom 6 problems. You have multiple choice here, or actually matching. These are matching. You've got A, this is A, B, C, D, E, and F. I would like you to take these 6 polynomials, and I want you to tell me, based on the left and the right behavior, the degree, tell me which is which. And tell me 22, he jumped to 22 and he said it's A. Why is 22A? The degree is 4 and there's 3 bumps, so I agree, that's A. Next.
19 is E.
Wait, what? 19 is what?
E.
19 is E, why? It's a linear. 2x, the degree is 1. Good. What's 20? It's D. Why is it D? X squared, and it's positive. 23. Negative x to the 4. It is C because both left and right are going down. 21, F, and 24, B. Got it. Easy? Okay, next. 43. Everybody look at 43. We have this beautiful polynomial here, right? And how do we know it's a polynomial? We don't have any sharp corners, breaks, turns. Answer these questions. Is the degree of this odd or even? And tell me why.
Odd.
Why is it odd? Because there's 4 bumps, okay, and what else? The ends are opposite. Tell me, is the leading coefficient negative or positive? Why? Because it's the left side's going down and the right side's going up. Can you tell me what the zeros are of this? What? Negative 2, 0, 4, and 6. Could you tell me the multiplicity of each zero if I asked you? Odd, even, odd, odd. Could you write this in factored form for me? Y equals x plus 2 times x squared times x minus 4 times x minus 6. Now answer D. What's the smallest possible degree that this could be? How did you get 5? You add these up. 2, 3, 4, 5. Does it make sense? Now, could it be anything else? Yeah, it could be a 7. And in that case, we would probably make one of these odd, like not a 1, but maybe a 3. You can make this a 4. But does this make sense?
Yeah.
Okay, try number 44. With the same questions. A, is this going to be odd or even, the whole thing? Even. Is the degree positive or negative? Negative. Can you tell me the negative coefficient? For C, what are the zeros? Negative 2, 0, and 2. Can you tell me, write this in factored form? Y equals x plus 2, x squared, not x squared,
No, x versus x.
just x, and then x minus 2 squared. And what would be the degree of this problem? The least is 4th degree. Okay, 2 more. Tell me how to factor this. Take out an x squared. And what are you left with? X cubed, 3x squared, minus x, minus 3. Now, how are we going to break this up? What are you going to do? What do you want to try? Let's try a 1. Let's see if 1 works. So we have 1, 3, negative 1, and negative 3. Does this work? Bring down the 1. 1 times 1 is 1. Add. Multiply. Add. Well, it worked. So, you have x squared, and then what should I write next? What should I write next? I want to write it factored completely. X what? Minus 1, and then you have x squared plus 4x plus 3. What do I do next? I'm going to factor this to be x plus 3 times x plus 1. All right, now can you tell me what to do next? Do you guys understand how to factor this? What do I do? Put a dot at where? 0, 1, negative 1, and negative 3. So let's start all the way to the left. Negative 3, negative 1, 0, and 1. What's the degree of this whole thing? A 5. So what are we going to do with this? It's going to come from the left, and it's gonna be shaped like this. But at one particular zero, what's it gonna do? It's gonna cross through all of them except
0.
0. So this is what it's gonna do. It's gonna come from here, it's gonna go up, it's gonna cross through here, and it's gonna bounce here at 0, and it's gonna go through like that. Now, how far up and how far down here, you would plug numbers like -2 or half, -1/2, and see how high up and how far down. And the last one, so you can make your T-chart and finish that. How do you do this last one? Take out an x, so that's a 0, and you're left with x squared plus 2x minus 8. How do you factor this? X plus 4, x minus 2. So what are your zeros? 0, -4, 1, 2, 3, 4, and at 2. So this thing's going to be coming down. It's going to go up. How high, I don't know. It's going to come down. It's crossing through all of these zeros. Why is it crossing through all of them? Because the degree of each zero has a multiplicity that's odd crosses. Now, how do I know how high and how low I would go? I would plug in numbers like -2 and a 1. So if you plugged a -2 and a 1 in here and did this, you'll get your two values. Can you do that really quick for me? -2 times 2 times -4, when you get, this is gonna be 16. So over 2 up, this would be 16 right here, so this thing's gonna go way up to 16, come down. And if you plugged in a 1, you have 1 times 5 times -1, you get -10. So over 1 and down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this thing would actually be coming down like that. Do you guys understand this stuff? Colin, turn that off. You guys have